I wrote this book because there isn't really a book on the market that helps students in a coherent way to work in the laboratory, to be able to analyse the data. Students see textbooks, which is a potted history more or less of science or engineering, but all the excitement that was there that created what's in the textbooks is lost. So where does the excitement come from? It comes from doing science, not reading about it, doing it. Well, to do it is you need to be a little rigorous and critical, and you need to be able to deal with the data you get and be able to decipher what's in there, to be able to manipulate it. And the book focuses on those things. So it's not a standard science or engineering textbook. It focuses on laboratory type work, which is critical to all scientists and engineers. Science and engineering progresses through experiment. It's not by accident. So the methods that students will learn in the laboratory or in the field are critical to their success as a scientist or engineer. To become accomplished, you need to master certain techniques and gain certain abilities. And the book is designed to help students develop these methods or these techniques and these skills. You should never take data at face value. You should always be aware that there's things interfering with the data you're gathering. So understanding errors, understanding the statistics behind errors, understanding how to deal with them and communicate them. These are key. You cannot just take things at face value. This book really says, look closely at your data, look closely at what is causing variety, disturbance within the data, and quantify that. Quantifying is very important. It's not just saying this is influenced by this or influenced by that. It's saying, well, by how much? And by how much turns you into a scientist or engineer rather than just someone who can speak generally about things. Communication has grown in its importance in science and engineering for very good reasons. Communication traditionally is reports or papers and journals, but more and more scientists and engineers have got to stand up and talk about what they're doing in a coherent and sensible way. And where do they get the support of that? Well, you can do it by trial and error, but this book actually has sections in it which help you to write a report, to do an oral presentation, to do a poster. Posters are a very important way of communicating. So there's a big emphasis in this textbook, on experimental methods and the communication of those methods. Students value explanations that are built on specific examples that they can relate to. And there are many examples in the book which are drawn from contexts that the students will identify and maybe themselves come across when they're in the laboratory or in the field. And so linking to that are many worked examples. So the students can work through examples, see how one example, how it's solved, and then there's plenty of opportunity to practice. And at the back of the book, there are solutions to all the problems. And students find that very useful. In the 21st century, very many people have smartphones, for example, and those smartphones can be used to gather data and analyze data. So there's a section within the book that deals with smartphones. There are more sophisticated approaches that students will adopt using computers to gather data, and the book touches on those as well. There's also the issue of communication and using things like spreadsheets and PowerPoint, things like that, which are many students are familiar with, perhaps in a different context, but we talk about them in the context of experimental methods, particularly what happens when students get data from a laboratory context or a field context. The internet is a very good source of information. However, it's disjointed. You really need to know what you're looking for and then understand what it means when you've seen it. So you can get many different explanations, for example, of errors in measurement and uncertainty, and sometimes they're contradictory. So who do you believe? That's a fair question. And so this book actually deals in a clear and concise and authoritative way with errors and uncertainty, and that area is one, though you find things on the internet, that's actually caused the students a lot of confusion. So the book as a whole is more coherent, I would say, than trying to pick things from the internet and put them together and understand them. I think that'd be very difficult unless you knew a lot about what you're doing and you're a very advanced scientist, for example, or a person with advanced knowledge. So one of the special features is that I actually show my logbook. Students have to record data. They could record it in a book or on a computer, but you rarely get to see someone else's logbook, and that's I think there's a lot of insight you can get from how do people record things, what's important, what do you jot down. Students often aren't given guidance in that, but in the book, early on, I talk about how do you record things, why do you record them. I'll emphasize this through an example from my own logbook taken from just a couple of years ago. I think if students have mastered experimental methods, they've mastered skills which will be of lifelong value to them. Experimental methods are key because they develop within students the capacities to communicate, to be critical about data, to look in very much more detail than they normally would at things that they are working on. Now these could be things which are scientific or technical, but could be of much wider range. So in fact, these methods are of long-term value irrespective of the career that the students will find themselves pursuing.